Good afternoon. It's my pleasure being here. So I've been introduced already, but what is missing from my bio is the fact at first I'm very happy being here. I mean, being in an event with real people in front of me, that look like obvious, but after 18 months, that's my first business trip, let's say. So I'm more than happy to be there, and I'm more than happy to be there to talk about security on IBM Z. So some of the concepts I want to talk about today was introduced already by Adam, and I will go in deep for some of them, and I bring also some interesting stuff I hope to cover with you today. If you have to keep in mind something regarding this presentation is you probably have all what you need regarding the security features function on IBM Z. But my recommendation at this step, it's my introduction, and that will be my conclusion. You should use them more. You should use them more because the market needs it. You should use them more because our customers, your customers, subscribers, damn it. I broke everything. Our customers or subscribers or industry or citizen and thank you. Yes. Forward. Okay. So yes. So a lot of people in different industry are counting on us. Their day-to-day services, payroll, the fact they can buy tickets for transportations, cash dispenser, and so on. They are not aware about it, but there is a mainframes or an interaction with the mainframe behind. We were not that exposed in the past, but living in a dangerous world, this thing has changed. And we have to be aware and to take this into account. Adam showed an interesting slide earlier. Over 14.7 billion of record breached. Only 4% of this breach record were encrypted. Only 4%. It means that some critical data outside of their security perimeter were exploitable as is. And that is an issue. The mainframe is more and more connected. It's inward and backward connected. The surface of attack is increasing. And one more time, we have to take this into account. So, as you can see on this slide, the mainframe is used by key organizations from the bank, from the industry, from the travel agency, from the automotive, from the telco, and so on and so on. So, the way we are living in our digital economy rely on the mainframe technologies and rely on what we are doing with our mainframes. So it has to be secured. It's a business, security is a business imperative. What I want to share with you is a landscape of the security. Security is not the sexiest topic, I know, but I would like to remind you what happened the past years regarding security on IBM Z. Some of you know this era because I was too young for sure. And at this time, we have a few digital assets that needs to be protected. And the best way to do that was to use the encryption. That's easy, selective approach. We need to decide which items or digital assets need to be encrypted, and then we start the encryption process. To make this as fast as possible, we start to introduce the first hardware crypto accelerators in the design of the machines. And years after year, release after release, decade after decade, we were able to improve the performance at the point where the encryption bandwidth is probably too much compared to our today business needs on the mainframes. A single core is able to encrypt up to 14 gigabytes of data per second. And as Adam said, we can configure up to 190 core on this machine. That's a huge amount of data. Providing hardware encryption accelerators was a thing, but rapidly it was not enough because of regulation and because of, finally, the amount of data that we had to protect. Then, pioneering, we introduced the concept of storage and tape encryptions in order to protect data breach from tamper removal or hardware bad maintenance happening at the storage systems or tape level, in case we lose a tape. That was good. That was quite pervasive. Let's say we are encrypting all of the data resting in the storage system at the tape level. But rapidly, this was not enough. The reason why? It's because once you are invoking the data from an operating system, the data is decrypted, flow in the clear on the network, and then it's served into the clear to the operating systems. This is why, after this internet era, from where we need to connect and interconnect networks, applications, third part, and so on, comes a new strategy in 2017. Pervasive encryptions. That was a breakthrough in terms of strategies. The reason why is simple, because it's a change in the paradigm. It's no more a matter of protecting data that must be protected, but it's about protecting all of the data. And if you have to remind a simple definition about pervasive encryption, it's a set of consumable features allowing you to encrypt data at speed and volume, at rest and in motion. So a set of consumable features you can use in order to minimize the risk where you identify the risk. That's the purpose of the pervasive encryptions. And protecting all of the data on the infrastructure help some of our customers to face quietly the GDPR regulations and others regarding data protections. 2017, 4 years ago. What's about the adoption rate? Not that fast as expected. Guess what? What is the reason behind? No one wants to lose the keys. What happens if you are losing the key? You create your own ransomware, but there is no way that you can recover. Okay? So that is, let's say, the last steps, let's say, or dependence before seeing a lot of our customers jumping into the pervasive encryption. But there are more and more jumping in. They are more and more doing proof of concept and checking their readiness to adopt several or all of these pervasive encryption consumable features. This is in the air. And the reason why is suddenly they realize that their laptop is fully encrypted. Their smartphone and tablet by design, by default, is encrypted. Their storage systems and their tapes are already encrypted. And why not the mainframe? So we see, let's say, an acceleration regarding the pervasive encryption adoptions and particularly dataset and volume encryptions to protect data at rest in the mainframe infrastructure. 2017, 4 years ago, we did significant progress toward a data security journey to protect the data on the mainframe infrastructure. But guess what? Rapidly, it was no more sufficient because new regulations are now about data privacy. It means appropriate use of the data beyond the data protections, meaning taking care of the confidentiality of the data. So data privacy is how can I be sure that those consuming the data has a business needs or the technical needs to do so. And if not, how can I be sure that I can change their experience consuming the data at the point of consumption or at the point of exfiltrations. So we open a new journey not on the data security, but on the data privacy, and we released the first technology pieces. First one was named Data Privacy for Diagnostic. It's a ZOS functions, helping to clean, to purge, to curate and dump from their business data, technical dumps. So if you have to share with an ISV or even with IBM a dump, so that we can fix and debug an applications using these functions, all of the business data or all of the data that are not technical will be removed from the dump. Then you don't have to sacrifice your compliance with your business agility. That's a first step toward data privacy use case and scenarios you can claim and expect with the mainframe. The second important masterpiece regarding data privacy is based on solutions introduced with the name of Data Privacy Passport, but now known as IBM HyperProtect Data Controller. It's an appliance managing, thanks to a fine-grained policy, the need to know, so that you can be sure that according to several groups, you can define what will be the experience consuming the data hosted on the mainframe or non-mainframes data sources, thanks to this policy. You may still grant the need to access to the resources. You can access, you can SQL query, but you don't have any business needs. So the output will be masked, encrypted, truncated, or hashed. You can query, but you can't understand fully the content of the data. Oh, you are recognized as a data owner. Same SQL query, the policy apply, and then the output is shared to you into the clear. That's type of use case we can develop now with the mainframes. This technology, this data privacy journey starts with the IBM z15 technologies in 2019. We are still resuming the data security journey, improving pervasive encryption capabilities, proposing more and more consumable features. Fiber channel endpoint security is a good one. If we are encrypting the storage box, okay, if we are encrypting dataset, probably not all of them, some dataset being not encrypted may flow in clear on the network. But if you are doubtful about your storage administrators, maybe you may want to encrypt the traffic between machines to storage systems, and this technology has been designed for that. Machine to machine, traffic is encrypted. Then the data is never exposed. As you can see, we are still improving the pervasive encryption, adding more and more consumable features. Quantum safe digital signature is quite interesting. We play big with encryption. So we have to be sure that the encryption of today is still secure tomorrow. This is why we are anticipating the quantum computing threats, proposing to use today algorithm. We know they have no grip with a quantum computing orchestrated attacks, type of brute force in a way. So we know we have already some quantum safe algorithm we can start to deploy, you can start to use in order to ramp up on this battle. You have to start now for a tomorrow threats. We will come back later with dedicated slide on that. That's two journey we're gonna see in details right now. Pervasive encryption. If you have to summarize the pervasive encryption concept, it will help you to protect the data on the mainframe infrastructure. So the data at rest and in motion will be encrypted. And the data at rest and in motion will be encrypted where you are considering the risk is. So the data here in the middle may rest on disk and tape. You can encrypt that. You can use full drive encryption, tape encryption, and so on. So in case someone wants to remove a piece of these systems or start a physical tamper attack, then your data remains safe and you are protected. Okay? That's not sufficient. This is why, because when the data is invoked at operating systems level, the data flows and is consumed into the clear at operating systems level. So if you decide to encrypt at operating systems level, you can, in the Linux side, use the volume encryption, encrypting all of the files that will be presented into the clear to authorize application, and the same from ZOS. Interestingly, from the ZOS side, you can define a fine-grained strategy deciding which datasets should be encrypted with what key. So you can isolate, segregate, let's say, and muscle the way you are protecting your digital assets on the mainframes. If the majority of your critical data are not on several types of datasets, but the majority being on IMS and DB2, you can use, of course, such database encryption mechanism to encrypt at field level, so that you can, let's say, reduce the risk according to, you can reduce the risk. But as you can see, the shape of the pervasive encryption pyramid here is a pyramid. And the reason why is, as close as we are from the application level, smaller is the surface, the coverage surface. So using tape encryption and disk encryption, we are protecting all of the data. Then dataset encryption is at LPAR level. We are reducing a bit, let's say, the coverage. Database is a subset of the rest of the data, and application level encryption is, one more time, a subset. So as you can see, pervasive encryption is a way you can compose what is required to start a real encryption strategy on your mainframes. Some customers start from the network side. They decide to encrypt all of their network sessions at first, and then when the time will come, when the governance regarding the key management will be set, they will start to encrypt the dataset. Some took the opposite way. They start to encrypt the dataset first and the network seconds. So it clearly depends on where you are considering the risk to be. Most importantly, this pervasive encryption strategy can be easily integrated with the rest of the security measures you may have in your environment. It means a SIEM, I'm sorry, I was surprised by the remaining time. With the existing security ecosystems you may have to protect identity and access management, to protect to start and to create your response in case incidents are detected. So basically, all of what you need to protect the data is there, and it is quite easy to integrate the pervasive encryption's consumable features into your corporate strategy. Rapidly, it was not enough, as I said. And this is why keeping the data safe with encryption, we know that to do that since a while, but we use also to focus too much on the need to access. It means, can you or can't you access to resources? Now we have to go beyond that. And that's the purpose of the data privacy journey. So data privacy journey is really about appropriate use of the data, because two persons may have the same access to resources, but one have a business needs to access this data, while the other one may have just a technical needs. So same access, but two different needs to know. And that's where data privacy solutions may be useful in order to protect better the data. Two simple use cases. We know how to protect the data on the platforms. We talk a lot about the pervasive encryption. But now we have, as I introduced to you earlier, some data privacy functions we can use and abuse in order to protect the data hosted on the mainframe infrastructure. And according who is querying and access to the data, a data source, an SQL database, for example, you can apply this data privacy policy. And then according who they are, a data owner, they will consume the data in the clear. That's normal. They are the owner of the data. But a data admin needs to guarantee the response times, the quality of the maintenance of the database. It has technical needs, not business needs. Querying the same SQL query, it will result to data being served a masked way. That's interesting. And you can imagine multiples, let's say, in between scenarios. We can protect the data at the point of consumption, thanks to a mainframe governance, protecting better the data hosted on the IBM's infrastructure or on others' technologies. It does not matter. The second use case is about protecting the data at the exfiltration point. As Adam said, we are applying the concept of data-centric and audit protections. It means security of the data stay with the data. So if you are preparing the data for being shared with a third party partners as a new data source, enriched with metadata, if the person is, the target is accepting such data, it accepts the security mechanism with. And if your relationship with this third party changed, then you can ensure that the data cannot be used anymore. You keep control. One more time, the governance remains on the mainframes. So, if you have to keep in mind about your today capabilities regarding data privacy, we can protect the data at the point of consumptions, thanks to a fine-grained policy, checking the needs to know of those willing to consume data hosted on the mainframes. And we can also ensure we can apply a secure exfiltration policy to guarantee that our data to be shared remains secured. And if we decide to turn them useless, we can do so. We play big with the encryption. And we have to be sure that we are properly prepared for what will come. We, IBM, are building this chandelier. Let's say it's a quantum computing machines. We are already selling such capacity available in the cloud for those deciding to jump into the quantum computing era and to change their way to develop application to benefits of this technology. Unfortunately, a popular use case is to break codes or brute force attack. And unfortunately, interesting target is the basics of the today digital trust in our era of the communication. It means digital certificate, encryption, integrity seal, and so on. If we cannot trust of these basics, then we will have a problem. This is why this is a battle that has to start now. There is a reason why. Panama Papers. What happens 20 years after we send people in jail? Because I can simply breach and steal the maximum of data today, and once Apple should be able to sell me a $2,000 quantum computing machines 20 years from now, I can decrypt the data I steal today. So the damage may be important if I start to steal encrypted data today and if I decide to value this stolen data tomorrow. So we have to keep this in mind. How to be prepared, and what's finally the value proposition of the IBM Z here? We introduced quietly the encryption algorithm rotations under the cover. So when the time will come, we'll be able to swap and to switch the encryption algorithm known for being vulnerable faced to a quantum computing computer-based attack to a quantum-resistant encryption algorithm. It's already there. Second, in order to ramp up with the use of this quantum-safe type of algorithm, we introduce the first draft IBM is pushing. As we did with DES, Triple DES, and EOS in the past, we did exactly the same thing, so that you can start to ramp up on that and to raise your skills in order to face this challenge that will be in front of us. I introduced these interesting future threats we are addressing today, but damn it, there are also future needs we are anticipating, still regarding the crypto. The way we are working today regarding the encryption is quite easy. The data is considered as safe when the data is encrypted. But there are a couple of use cases from where the data may not be that safe. Example, key rotations. I need to decrypt the data to change the key and then to encrypt the data with the new key. That's a use case. Second, if you want to value the data, you have to work on data into the clear. So you have to decrypt the data. At least you have to trust the one who's gonna compute or value the data with a data processing process. So that makes sense. That's the issue we have today. But what if we can compute without decrypting the data? It looks like a magic thing, but thanks to our mathematicians, we are able now to exploit the properties of mathematics And the name of this technology is homomorphic encryption or fully homomorphic encryption. The basics behind is operations applied on encrypted data are stable once the data is decrypted. So if you look for the presence of a string, or if you are using simple operations like additions, subtractions, and so on encrypted data, once the data is decrypted, it looks like it happened on the encrypted data. That looks like a magic. It opens the gate to new use cases, because now you can share data knowing that this data will not be decrypted by those to be in charge to value this data. So basically you are reducing the risk. You are reducing the risk with third parties, or those you have a relationship to value the data via a data valorization process you cannot do by yourself. An example, and I'm sorry for those being in the back of the room, but I will explain. Okay, this is my organizations. I have a transaction database, but I'm not able to perform a machine learning, some machine learning processings, because I don't have this elastic cloud capacity. So in the past, I used to share training samples and some transactions, so that the predictive engines using the machine learnings may apply in the cloud, and then they send back to me their predictions. This is how we used to work today. With fully homomorphic encryption, the things will be different. The data is in the clear in my organizations. I prepared a subset of transactions that I'm going to share an encrypted way with the cloud service provider. I prepared some training samples that I'm going to share an encrypted way with the cloud service provider. Using these training samples, it can apply the machine learning processing, and then the prediction engines from their side can work based on encrypted data. Predictions are encrypted, and this is exactly what is delivered to me. Decrypting the predictions, I can enjoy the job done. Nowhere in this use case, the data were exposed into the clear at the third party level. So we just solve an issue with the need to share and the degree of trust we may have with such partnership. And this will probably open the door to various type of use case, helping us to minimize the risk. So what's the point with IBM Z infrastructure? We do believe that is cool at first. We do believe that is an area from where the IBM Z can play its role. And that is part of the trends and directions. Today, the first technology bricks, the first toolkit is available so that you can test several proven use cases on your mainframe infrastructure. It supports the IBM Z and the Linux One architecture. And we are ready already to help you to develop your use case, knowing that the machine will be faster and faster executing and delivering such services in the future. I would like to, after anticipating the future regarding threats and future needs, to say some few words, or additional few words about the IBM Telum. We succeed in a way protecting the data on the mainframe infrastructure, and we have more data than ever to be protected. We have the pervasive encryption, no problem at all. But customers are expecting more to value these tons of data they have. And the best way to do that is to use artificial intelligence and to speed up such data analytics or data transformation functions as close as possible to where the data is. So the Telum has been designed also for that, to speed up the processing, getting insight from these tons of data. So it could be business data or operational data. So we will be happy to use these enhancements for our compliance, for configuration check, and for other interesting security use case using these AI technologies in the future. Some words about what's new with this chip, encrypted memory. So we are now protecting data at rest, data in motion, and tomorrow, data in use. Thank you for your attention. I was more than happy to cover this topic today. Most of the time, I am the last speaker of the day. So finishing with the security, it's not the best thing to do, but you survive. And if you have any questions, just let me know. I will be more than happy to cover some more with you. Thank you.